General pruning training video. Pruning is the selective removal of various parts of a plant. Benefits: it encourages health and vigor, increases longevity, improves the quality and/or quantity of flowers, foliage, and fruits, helps control the size and shape of the plant, etc. There are many ways to prune, and because pruning is a combination of art and science, there isn't necessarily a right or a wrong way to prune. In fact, sometimes even similar tasks can be approached differently based on factors like the arborist and the client. And again, no one method is necessarily right or wrong. However, and this is a big however, as you use different pruning equipment and different pruning techniques, you will likely see trade-offs in the health, the appearance, the longevity, and the blossom productivity of the plants you prune. And because BYU is concerned about all these things, BYU has its own guidelines as to how we prune. Landscape design. Successful pruning begins with appropriate landscape design based on an understanding of plant genetic behavior. And in fact, because features such as plant growth patterns, shapes, sizes, and other plant needs are genetically predetermined, it is impossible to compensate for inappropriate plant design with pruning. That said, landscape design considerations can include a variety of plant-related factors: desired height and width at maturity, square footage of the bed, distance from plant to window, plant to sidewalk, and plant to plant, rate of growth and natural growth habit, genetic timeline of blossoms, fruits, and flowers, desired color of the leaves, flowers, and blossoms, life expectancy, water and pH needs, salt tolerance for plants near roadways and sidewalks that are treated with salt during snowy seasons, diversity of species to add variety and to help discourage plant disease and insect infestation, maintenance considerations such as fragrance, thorns, skin irritants, etc., and the list could go on. But the point that we're trying to make here is that it's important to understand our environment, it's important to understand the needs of the plants we're considering, and we ought to make sure the two are a good fit before we buy or install anything. Assuming that we've got an appropriate landscape design and that our plants have been properly installed, we're ready to begin looking at how to maintain them. 3 questions of pruning. Before we make any pruning cuts, we ought to consider some basic questions, like why, when, and how. First off, why prune? Pruning reduces or maintains plant size, removes dead, damaged, and diseased branches as well as branches growing in an unwanted direction, stimulates flower and fruit development, rejuvenates old and established plants, shapes plants into hedges, espaliers, topiaries, etc., and helps complement the plant's natural habit or growth pattern. Next, when should we prune? When it comes to pruning, timing matters. Timing can affect growth response, including flower and fruit development, health and wound exposure, etc. To understand this effect, we need to understand some basic plant biology. Plants go through a number of phenological stages, or periodic plant life cycle events, during a 1-year cycle. The number of phenological stages can range from something like 3 to 8 stages and depends on things like the type of plant and how the technician divides the phenophases. All woody plants operate on an energy budget, and this energy budget is spent differently depending on the phenological stage the plant is in when it's pruned. The best time to prune depends on things like the species and the desired results. That said, if our objective is to remove dead, diseased, weak, or undesirable stems, broadleaf evergreen stems and deciduous plant stems can be removed at any time with little negative effect. Meanwhile, narrowleaf evergreens should not be pruned when wood is frozen, and they would ideally be pruned before midsummer in order to minimize the risk of pest problems associated with wounds and to allow enough time for new growth to emerge and begin closing and compartmentalizing the wound before the following winter. If our objective is to cause a vigorous response, growth is maximized when pruning is done near the end of the dormant stage, before buds swell, such as in late winter or early spring, but prior to the most active growth in the spring. If our objective is to cause a less vigorous response, plant growth can be reduced by pruning during or soon after the initial growth flush. Regardless of the desired objective, it is important to be aware of the stress level of the plant. Plants expend a great deal of stored energy to produce roots, foliage, and early shoot growth during the initial growth flush, and removing too many live branches at this time can stress a plant that needs its live foliage to help recover. Furthermore, wounds created by pruning cuts provide access to pathogens. That said, and if possible, susceptible plants should not be pruned during active transmission periods. Now, all that said, everything we just mentioned in the above 5 bullet points, those are the best pruning practices we are aware of as far as it relates to the question of when to prune. However, we understand that this is the ideal, and we don't always have all the necessary resources to prune ideally. And that said, it's important to be aware of plants such as roses that are more sensitive to pruning timelines and prioritize accordingly. Third, how do we prune? At the beginning of this training video, we talked about how there are many different ways to prune, and we talked about how there isn't necessarily one right or wrong way. How we prune can include factors like pruning tools, plant shapes and characteristics, plant anatomy, appropriate pruning cuts, boundaries, etc. That said, we'll take a brief look at each of these factors, and then we'll get into some specific projects. Pruning tools. That concept of right and wrong includes the tools we use, since different tools will have different effects on both the health and the appearance of the plant. Here's a brief introduction to some of the tools we use to prune. Hand clippers, hand pruners, or hand cutters. There are 2 types of hand clippers, anvil and bypass. Currently, we use bypass hand clippers because they result in less stem crushing, make cleaner, closer cuts, and have proven more robust. Bypass hand clippers function like scissors. To use them, we typically place the larger flat blade close to the collar/parent stem. Doing so helps make smoother, cleaner, closer cuts. Factories recommend using hand clippers to remove stems up to 3/4 of an inch in diameter. Loppers, pruning loppers, or shearing loppers. Similar to hand clippers, loppers come in 2 different styles, anvil and bypass. And again, we currently use bypass loppers because they result in less stem crushing, make cleaner, closer cuts, and have proven more robust. Factories recommend using loppers to remove stems up to 1.5 inches in diameter. Pruning saws, hand saws, or reciprocal saws. Currently at BYU, we typically use a battery-powered reciprocal saw because it allows us to get into tighter spots and make smoother, cleaner, closer cuts with less time and effort. Technicians recommend using a pruning/reciprocal saw to prune stems up to 3 inches in diameter. Chainsaws. Technicians recommend using chainsaws for stems larger than 3 inches in diameter. Shears, hedge trimmers, or hedgers. Shears are tools that use opposing cutting edges to create a scissors effect. They can be useful in situations where we want to quickly make a large number of small diameter cuts, such as with a long hedge. The factory recommends using shears to prune stems up to 3/4 of an inch in diameter. Regardless of what tools we choose to use, all tools should be kept clean, sharp, and in good working condition. Using sharp, well-maintained pruning tools helps to create smooth, clean cuts. Smooth, clean cuts make it easier for a plant to compartmentalize or seal off the wounded area. And the more quickly a plant can compartmentalize or seal off the wounded area, the less vulnerable it will be to things like disease and infestation. Plant anatomy. Plant habits and formations. Because of their genetic makeup, plants tend to innately behave in more or less predictable ways. That more or less predictable behavior can include factors such as size at maturity, shape or habit, specific branching patterns, and growth rate. At BYU, we try to prune in a way that encourages more of a natural look and helps to preserve the essential character of the plant. Specific plant habits and formations include arching, cascading, climbing, columnar, espalier, fountain-like, hedge, low-spreading, mounding, round, and upright. A plant with an arching habit is one that is generally round, but whose cane tips bend back towards the ground, creating a weeping effect. Cascading formation. A plant that cascades is one that typically has a low-spreading habit and is trained to spill over and down the sides of a raised bed to help create a waterfall effect. Climbing habit. A plant with a climbing habit is one that is typically low-spreading, but is permitted rather than trained to grow up the sides of structures such as walls and fences. Columnar habit. A plant that is columnar is one that is taller than it is wide. Espalier formation. Espalier is the practice of shaping plants into flat, often wide formal patterns that are supported by structures such as walls or latticeworks. Fountain-like habit. A plant that is fountain-like is one that has branches spilling out in arches, but unlike a plant with an arching habit, its cane tips don't typically bend back towards the ground. From an aerial view, plants with a fountain-like habit often appear star-shaped or snowflake-shaped. Hedge formation. A hedge is a row of plants that have been trained to grow together. Low-spreading habit. Plant with a low-spreading habit is one that has stems that typically grow horizontally over the ground's surface and is often many times wider than it is tall. Mounding formation. A mounding formation is a formation created by permitting multiple plants to grow together in a rounded mass. Round habit. A plant that is round is one that is about as wide as it is tall. Upright formation. An upright formation is a formally maintained columnar plant. Forms. Plants have two basic forms we're going to focus on during this training: single-stemmed and multi-stemmed. A plant that is single-stemmed is one that has one central stem, like a typical tree, from which all the other stems subdivide. A plant that is multi-stemmed is one that consists of a cluster of stems usually originating near the soil line of the plant. Single-stemmed and multi-stemmed plants can be evergreen or deciduous. A plant that is evergreen is one that has foliage throughout the year and always appears to be actively photosynthesizing. As a side note, an evergreen does lose its foliage, but it loses it gradually and not all at once. A plant that is deciduous is one that prepares for dormancy by shedding or dropping various parts of the plant, such as leaves in the fall. Fruit/flower buds. Plants can also be classified by the age of the stems on which their flower/fruit buds are formed. Knowing this matters because at BYU we want to do what we can to encourage a brilliant flowering. There are three general categories of stems on which flower/fruit buds are formed: those that develop buds on growth that is 1 or more years old, those that form buds on the current season's growth, and those that produce buds on both old and new growth. Growth on 1 or more year old wood. Some plants blossom in the early spring. These flowers typically form on 1-year-old wood and are born from buds that had developed during a previous growth episode. Pruning these plants during the dormant stage will remove many of those buds, resulting in fewer flowers/less fruit in the early spring. Pruning these plants right after the flowers fade will give the responding growth enough time to develop and mature new buds before winter, creating a brilliant flowering the following spring. As a general guideline, Utah plants that bloom before June 1st flower on the previous year's wood. Current season's growth. Some plants begin blooming in the late spring and continue blooming into the summer. Their flower buds form on the current season's growth and appear at both the tips of and along the new stems. Pruning these plants while dormant will stimulate the production of new growth, which is needed for the continual showing of flowers. Growth on both old and current season's growth. Some plants blossom on both old and new growth. This can be achieved by preserving a combination of old and new wood. To accomplish this, old growth would be pruned more aggressively, and new growth would be pruned more lightly, leaving as many strong new stems as the plants produced. At BYU, and in each of these instances, we do what we can to encourage a brilliant flowering. At the moment, we don't have the resources to always prune ideally, but again, we do the best we can to preserve the natural characteristics of the plants. Apical dominance. The points where buds originate or attach to the stem are called nodes. The space between nodes is called the internode. The apical/terminal bud is the bud at the tip of the stem and grows the fastest. The other buds are called lateral or axillary buds. If the apical bud is removed, the bud next in line will become the dominant apical bud. Apical buds produce hormones called auxins. These hormones focus plant energy into the apical bud, allowing it to grow vigorously. Auxins also flow down the stem and help suppress the growth of lateral buds. Appropriate cuts. Again, at BYU, one of our goals is to preserve the natural characteristics of the plants on campus. Preserving the natural characteristics of a plant is accomplished by making a series of appropriate cuts. An appropriate cut is a cut that is made in the proper place, at the proper angle, and is clean. This is what's known as natural target pruning. In order to make a cut in the proper place and at the proper angle, it's important to locate the branch collar and the branch bark ridge. The branch collar is a swollen area that encircles or nearly encircles the branch at its base. The branch bark ridge is a strip of raised bark where overlapping fibers meet at the base of the branch, just above the branch collar. Proper place. A proper cut is a cut that is generally made as close as possible to the outside of the branch collar without going through it. Proper angle. A proper cut is a cut that is perpendicular to the growth axis at the point of attachment. There are 4 main kinds of cuts: 2 kinds of thinning cuts and 2 kinds of heading cuts. Thinning. A thinning cut is a cut that removes an entire stem at its base, or a lateral branch at its point of origin. Thinning is a pruning technique that can be used to preserve a plant's natural growth habit while achieving a more open framework of branches. Thinning can help make a plant less compact, less dense, or thinner. Doing so lets in more light and air, which helps the plant green up on the inside. Otherwise, plants will get fuller and bushier, continue to thicken up on the inside, and grow until they are finally out of bounds. And then when they need to be reduced, it leaves the plant looking like this because again, the sunlight can't penetrate the canopy to help green up things on the inside. Thinning can also help rejuvenate mature plants by removing and reducing older, thicker branches. Doing so can help make room for new growth and extend the lifespan of the plant. Thinning can be used to help improve the structure of a plant by removing things like dead, damaged, diseased, weak branches, branches growing in an unwanted direction, or branches that are rubbing together, since branches that rub together sometimes open up the plant's bark and create a potential entryway for disease and insects. Thinning can also help to restore plants that have deviated from their natural habits due to things like neglect or inappropriate pruning. Thinning cut number 1. Removal cuts. A removal cut is a cut that removes an entire stem at its base. To make a removal cut, we remove stems back to parent stems. A parent stem is the larger, thicker stem from which the smaller, thinner lateral originates. That said, and depending on the plant, we may have a number of different options when it comes to making removal cuts, any of which would be considered appropriate. So, for instance, with this particular plant, we could make a removal cut here and remove this smaller lateral branch because it branches off of this larger parent stem. We could make a removal cut here and remove this smaller lateral branch because it branches off of this larger parent stem. Or we could make a removal cut here and remove this smaller lateral branch because it branches off of this larger parent stem. And again, all of these cuts would be considered appropriate, and all of these cuts would be considered removal cuts because we're cutting back to a parent stem. Thinning cut number 2. Reduction cuts. A reduction cut is a cut that removes a larger, thicker stem back to a smaller, thinner lateral branch. At BYU, for structural and health reasons, we try to prune back to parent stems or strong lateral branches. A strong lateral branch is a branch that is at least 1/3 the diameter of the parent stem. That said, depending on the plant, and similar to what we talked about with making removal cuts, we may have a number of different reduction cut options, several of which may be considered appropriate. So, for instance, with this particular plant, we could make a reduction cut here and remove this larger stem back to a smaller lateral branch. We could make a reduction cut here and remove this larger stem back to a smaller lateral branch. Or we could make a reduction cut here and remove this larger stem back to a smaller lateral branch. And again, all of these cuts would be considered appropriate, and all of these cuts would be considered reduction cuts because we're cutting back to a lateral branch. In any case, and regardless of the location of the cut, reduction cuts are made by cutting larger stems back to strong laterals just beyond the point of attachment. Heading back, or directional pruning. In routine arboriculture and at BYU, the general rule of thumb is to prune back to strong lateral branches whenever possible. Doing so helps branches to develop good branch taper, which helps to encourage good plant structure, and creates a smaller wound, which aids in compartmentalization. Even so, and when that's not possible or advisable, or when we're looking to control the direction of the plant growth, it can be acceptable to make heading cuts. A heading cut is a cut that removes a portion of a stem that has not been pruned back to a strong lateral branch. In other words, a thinning cut is a cut that prunes back to a strong lateral branch, whereas a heading cut is a cut where a stem is pruned back to a lateral branch, but it is not a strong lateral branch. In other words, a lateral branch that is less than 1/3 the diameter of the cut stem. Or a heading cut could be a cut made at an indiscriminate location that isn't a lateral branch at all, like an internode. Heading cuts can be used to control or redirect growth. Stems tend to grow in the direction they are pointing. Again, and like we talked about previously, when a stem's apical bud is removed, the bud next in line becomes the new apical bud, and the stem will tend to grow in the direction the new apical bud is pointing. This type of directional pruning can be useful in controlling growth with plant formations like espalier. Heading cuts can also be used to create and increase lush and dense foliage with, for example, plant formations like hedges. Heading cuts can be used to help stimulate new flower formation. And heading cuts can also be used to reduce the size of a stem in cases where a thinning cut would be too aggressive, like in prominent areas, or when a thinning cut wouldn't allow enough time for a plant to recover and look good for an upcoming event like graduation. There are two kinds of heading cuts, a square or 90-degree cut and a slanted cut. At BYU, our preference is to make square cuts. Square cuts or 90-degree cuts. A square cut is a heading cut that removes a portion of a stem at an angle perpendicular to the stem, about 1/4 of an inch above the node. Pruning any higher than that will leave a stub, which is both unsightly and creates a potential entryway for disease or insects. Pruning any lower than that may cause the stem to dry out and die. That said, and depending on the plant, we may have a number of different options when it comes to making heading cuts, any of which could be considered proper. So, for instance, with this particular plant, let's say we're considering removing a portion of this stem here, and we've decided in this instance it's more advisable to make a heading cut rather than a thinning cut. We have nodes here, 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 and here, none of which qualify as strong laterals, and so we can make heading cuts at any of these points, about 1/4 of an inch above the node, perpendicular to the stem. Additional considerations. So we've talked about appropriate cuts, including things like the location, angle, and smoothness of the cut. We've also talked about pruning ideally and how there are instances where it might not be possible or advisable to prune ideally. But the question remains, how do we know when to use which cut? And how do we know how much material to remove? Again, and like we've talked about, at BYU we try to prune in a way that encourages more of a natural look and helps to preserve the essential character of the plant. To do this, we remove all dead material and any damaged or diseased material unless it will cause the plant to look imbalanced. We remove up to 1/3 of the older, thicker branches, including anything that is weak, growing in an unwanted direction, as well as branches that are rubbing together, again inasmuch as it doesn't leave the plant looking imbalanced. To encourage more of a natural, less formal or sheared look, we also vary the lengths of the remaining stems that form the outside edge of the new canopy. Exceptions. Plant removal. In the section above, we talked about removing dead plant material. But the question remains, how dead is too dead? The current instruction we've received is that if a plant is 60% dead or more, we are to remove the entire plant. Thinning. We also talked about removing up to 1/3 of the older, thicker branches. However, in areas where the area is too prominent or the plant won't recover and look good in time for an upcoming event like graduation, we might consider removing less plant material. Shearing. Shearing is the process of cutting something with shears. Many landscape crews often use shears to quickly make a large number of small diameter heading cuts, such as with certain prolific species of multi-stem plants, low-spreading plants, and hedges. And again, like we talked about at the beginning of the training video, doing so isn't necessarily right or wrong. We also talked about the likely trade-offs in areas like the health, the appearance, and the longevity of the plant based on the tools and the techniques we use. And shearing is one of those techniques where those trade-offs will almost definitely be noticeable. At BYU, shearing is done on a case-by-case, area-by-area, species-by-species basis. As a general guideline, we try and follow the factory recommendations and only shear stems up to 3/4 of an inch in diameter. We strongly recommend avoiding shearing plants with large leaves because the damage to the leaves is unsightly. We strongly recommend avoiding shearing plants with large internodes because shearing them typically leaves a stub. We should consider touching up any cut, and particularly any large diameter cut that isn't smooth and clean. And when shearing plants like low-spreading ground covers, we thin out the older, thicker stems and also bevel and vary the lengths of the stems at the edges of the plant bed. BYU specifics. So in the above sections, we talked a lot about general pruning practices that could be applied to situations throughout the world. In this section, we're going to talk about practices that are specific to the grounds at BYU. Boundaries. In addition to the health, the appearance, the longevity, and the blossom productivity of our plants, it's also important to keep them in bounds. Simply put, boundaries deal with controlling the size of a plant. Controlling the size of a plant helps with things like accessibility for maintenance crews that work in or around the plant bed, and visibility, for instance, in areas near building windows and parking lots. To do this, we try to leave enough space to sidle through plants, including between plant rows as well as between plants growing in the same row, and we try to keep plants off walls and catwalks, below non-basement windows, and away from things like fire hydrants, valve indicators, utility boxes, floodlights, etc. Exception: sometimes certain species of plants are trained to cascade over things like walls or raised planter beds. Otherwise, we try and keep plants inside their bed, regardless of what the border consists of: grass, mowing strip, planter box, sidewalk, curb, parking lot, road, etc. Larger background plants. Our current grounds director prefers that we maintain larger background plants at either 1/3 or 2/3 the height of the adjacent building for artistic reasons. And for ease of maintenance, we typically choose to maintain our plants at no taller than 1/3 the height of the adjacent building. General plant height. At BYU, the preference has been to maintain plants at the same height when those plants are members of the same species and are planted in the same row, or when those plants are planted in close proximity to each other. Tiered plant beds. When plant beds have multiple rows of plants and the intent is to provide a tiered effect, the foreground plant is maintained at a height no taller than 2/3 the height of the background plant. Cascading plant beds. Sometimes there are plants planted below the cascading portion of our formation. When that's the case, we try to leave enough space between rows to sidle through the cascading portion and the plants planted below the cascading portion. We also want to maintain enough space between the two plants so that they don't appear to run together vertically. We train the plants planted below the cascading portion of our formation to be about 1/3 the height of the raised bed, and we train the cascading portion of our formation to spill over and grow about 2/3 of the way down the remaining 2/3 of the space not occupied by the plants below. Short-term and long-term plant bed goals. At BYU, there are both short-term and long-term plant bed goals. When plant beds are first installed, one of the goals is to have the plant bed appear full. However, as plants mature and begin to overlap, short-term filler plants are subordinated and pruned back and potentially removed to make room for the maturing plant that is intended to occupy that space in the long term. Fences. We prune plants to the height of adjacent fences. Any lower than that leaves the fence exposed, and any higher than that can make the plants difficult to maintain. In order to help mask the fence, we will also not separate the plants. Parking lots. BYU often hedges plants that surround parking lots in order to funnel foot traffic toward crosswalks. Conclusion. This is the end of the general pruning segment of our training video. In the segments that follow, we'll talk about some specific projects, specific species, and specific plant formations.